Question 1. Explain the meaning of differentiation and what are the techniques of differentiation. What is differentiation? The process of finding rate of change of a function mathematics. It used to calculate how a function changes with respect to a change in its input. What are the techniques of differentiation? Number 1 is power rule. Used when differentiating function of the form f(x) equal to x number. Next, we go to product rule. Used when differentiating the product of functions. Next, number 3 is quotient rule. Used when differentiating of the division of two functions. Next, number 4 is chain rule. Used when differentiating of a composition of functions, a function inside another. Next, we go to number 5, implicit differentiation, when finding the derivative of a function where y is not explicitly defined in terms of x.
Question 2. Find dy dx for the following function. A. 3x squared sec bracket x plus 2. Based on the equation, it is clear that the only suitable method for us to differentiate the equation is by using product rule. Now, we must differentiate between u and v. 3x squared is the u and sec x plus 2 is the v. When using product rule, we must differentiate each component. So when we differentiate u, it will be u prime equals to 6x, while v will become v prime equals to sec x plus 2 and tan x plus 2. Now, we must insert all the components into the product rule formula. The formula is dy over dx equals to uv prime plus vu prime. We must insert all the components carefully into the formula to avoid any careless mistake. After inserting all the components into the product rule formula, we must expand and solve any possible work until there is nothing left to do. After finish doing expansion, now all that is left to do is doing rearrangement. The purpose of doing rearrangement is to make the final answer look neat and easy for the examiner to understand your final answer. After certain rearrangement, your answer will be successfully complete and correct. Now let's look at question B. Since the equation is in a rational form, the only suitable method for us to differentiate this equation is by using quotient rule. In quotient rule, we must split the equation into two components, which the numerator will be u and the denominator will be v. So 4x plus 2 will be the u component and cos x will be the v component. Now, we must differentiate u and v component, which means that u prime would be 4 and v prime would be negative sin x. Now, we must insert each component into the quotient rule formula. The formula is dy over dx equals to vu prime minus uv prime over v square. After carefully inserting all the components into the quotient rule formula, all that is left is to solve any possible work and also any possible rearrangement. Now, we have successfully completed question 2.
Hi, my name is Yasmin and I will be explaining how to solve question 3. So on the screen we can see the equation. So first step is to split the equation into 3 different components. So first component will be y ln 3x. First, we'll split y and ln 3x into 2 different parts, y being u and ln 3x being v. We'll differentiate y into 1, and when we differentiate ln 3x, ln will be a different component and 3x will be a different component. Differentiating ln will turn into 1 over x, but since we have a 3, it will be 1 over 3x. Differentiating 3x will turn into 3, and when we put them together, we will end up with 1 over x. Next, we will use the product rule, which is dy over dx equals to u v prime plus vu prime. We'll put in the uv's into the product rule, and we'll solve it. So in the answer, we'll get dy dx times with ln 3x plus y over x, and that will be our final answer for component 1. As for component 2, we'll differentiate only the power of the exponent. So when we differentiate 2x plus 1, we'll get 2. And we'll bring that power to the front, and the final answer will be negative 2 exponent 2x plus 1. And for negative tan 4y, which is the third component, we'll differentiate it d over dx. So when we differentiate negative tan, we'll get negative sec squared times 4y. And when we differentiate 4y, we'll get 4. So we'll expand the equation, and we'll get dy over dx equals to negative 4 sec squared times 4y. And the second step is to bring all of them together. So we'll bring component 1, 2, 3 in one single equation. So on your left hand side, you'll have the dy dx equations, and on your right side, we'll have the dx over dx, which is non-dy. And the final step is to factorize. What we want is dy dx on the left side only. So we'll factorize ln 3x minus 4 sec squared 4y into one place so that we can move it to the right side. So when we move it to the right side, multiplication will become division. So our final answer is dy over dx equals to 2 exponent 2x plus 1 minus y over x over ln 3x minus 4 sec squared 4y.
Now, let's move to the last questions. So, this is the step-by-step calculation using the linear approximation method to estimate the value of the first root of 80.99 minus 2 over square root of 80.99. The process begins by defining a function f(x) equals to x power of 1 over 4 minus 2x power of negative 1 over 2. And then, finding its derivative f prime x equals to 1 over 4x power of negative 3 over 4 plus x power of negative 3 over 2. To approximate the value at x equals to 80.99, a nearby value x naught equals to 81 is chosen. The difference dx equals to x minus x naught is calculated as negative 0.01. The linear approximation formula f in round bracket x naught plus dx equals to f open bracket x naught close bracket plus f prime x naught dx is then applied. The values of f in bracket 81 and f prime 81 are computed and substituted into the formula, along with dx equals to negative 0.01. After simplification, the approximation of the first of 80.99 minus 2 over square root of 80.99 is found to be approximately 2.778.